Hello and welcome to the second session of Learning AI. And this session is really about the learning of in the Perceptron model. So basically what we want to do is today is now, if we assume we have a model that looks like this, we have three inputs. First one is the bias, so it's always 1, x0, x1 and x2. These are our two expressions, and we want that network to produce as output the logic OR function. What we are looking at is how, based on the difference between what the network computes when we just feed in these numbers, so that would be the output of the network. We want, and if we compare that output of the network to the value we expect, we can observe whether the network produces an error or not. And if the network produces an error, what we do is we modify these weights. That's when we talk about learning, that's what's happening. So we have the network produces an output, we compare that output with some expected output that we have to write into our program, and based on if there is a deviation, if there is an error, then we modify our network structure. I have again set up a page on my personal blog, because there I can include code and also typeset. So this is also called error learning, because we use the concept of an error. The error is actually this deviation of what we expect. So the expected output I call here y, and I make a difference between the expected output and the output the network renders. What is important here is that when we talk about output, because of the threshold function, the only output the network produces is either a 1 or a 0. Okay, that's something that simplifies this whole the whole mathematics here. And basically, if there is no difference, so if the output of the network is what we expect, then the error is 0. And the important part for this learning is this equation here, where we compute what is called the delta. It's another Greek letter that is usually associated with change. We compute the delta of the weight. So we compute the change of the weight, delta Wi. It's the same. We use one formula for adapting the weights for every weight. So this weight has the same equation as this one, and this is marked with this little index I. So the change of the weight is a function of, first thing is, this is called lambda, another Greek letter, and this is the learning rate. This is usually a value lower than 1, between 0 and 1. In the code, I think I've set it to 0.3. It's something you can experiment with. You can play with the code. So this controls how strong one deviation or one error will affect the change, basically. Then this is multiplied with the error. So if the output of the network is equal to the expected output, the error is 0, and thus there is no change. This will the whole expression will become 0. If there is some deviation, then the change of the weight that connects, for example, the input with index 0 to the output will be changed towards the input with the same index. So here is actually the input xi. And then once we have computed the change, the next step to do is what is called to integrate that. So our new weight is the old. When I put the index here, the old weight plus the delta of the weight, and that we do this for every weight. This is the mathematics behind, and this is what is called learning in neural networks. I want to guide you through the code. So what we have here is the first thing is that we define our input variables, so all possible combinations again. Here you see 0, 0, 0, 1, 1, 0, 1, 1. The next is I define a weight vector, and I have defined the weight vector here so that the system really has to learn something. So with this weight vector, the network will not produce the OR function. There will be some error. So each weight here is set to a value of 1. And you can already, if you are in it already now, you see that if all values are 1, that even if those two are 0, because we have this summation here, there will be the sum for the first part of the truth table. So I quickly draw the truth table again. For the OR, this first 0 here, it's not going to work out with the weight setup like this. So I've chosen it so that the network has to learn something actually. And then here, this is an important part of the code. Here we define what we expect the network to produce. So this is basically what is defined here. It's our y. And the rest, here you have the learning rate, and the rest is kind of like just controlling the setup of the program. So if I start the program, it's a program that draws this network. So we have our three nodes. Node 1 here up here is always 1. When the node is 1, it has a color of red. When it's off, it has the color black. We are actually looking at this constellation here. So if here this is actually x2, it's on, so the network has to be on. Nothing is changed. With the letter n, I can step through and look at the next sample. This is the other example, this one. And again, nothing happens because the network produces the right output. When both are on, it's fine as well. And now comes the interesting part. Now we are here. x1 and x2 are 0, but our network produces an output of 1. That's because the bias term is kicking in here. And what you see is now that it has changed by the amount of the learning rate and the error. So the new weight is not 1 anymore, but 0.7. Now we can step through. And what is interesting to see is that change in the network only happens when there is when there is a when there is an error. Otherwise, nothing changes. And now something interesting has happened. Now the weight of the bias term has gone below 0, and now after the error occurred, and from now on the network is going to produce the OR function. So let's go through it. See here, both are on, and now it's doing the correct thing here. And now actually the weights are not changing anymore. That's it. So this network has now learned the OR function. There are two more exercises. The first exercise is to modify the code so that the network, instead of learning the OR, learns the AND function. So basically the truth table it produces should look like this. So only when both are on, we want the AND function, the output to go on. That's the first thing to modify, to dig into the code and find the right spot where you have to change so that the network learns the AND function. The second task is to extend it to really go into programming and to make a slightly more complex network that looks like this. So we have again the 3 input nodes, but we have 2 output nodes. One should be associated with the OR and the second one with the AND. So basically the network connectivity will look like this. This is always on, and you should program it so that it learns in parallel the OR and the AND, given those input patterns. Yeah, that's it basically. Have fun with the exercises. The idea is that you please note every problem that you don't understand, so we can discuss the solutions later on when we meet again. Thank you and see you soon.